Hello again. So in this video we're going to look at factoring trinomials. Alright, what is a trinomial? Tri, the first three letters there stand for 3. Alright, and we're going to be looking at 3-term polynomials. Alright, and we're going to be focusing on trinomials where we've already factored out the greatest common factor. Alright, and so we're going to break this into two cases. We're going to focus on, in this video, the case where the number in front of the squared term is equal to 1. So what we're really dealing with here in this video is x squared plus a number times x plus another number. We could have a different variable instead of x, but the main thing to know is that we have a trinomial where we have a squared term, a linear term, and then a constant term. We're going to handle this differently for when the number in front of the squared term is 1, which we're calling little a here, versus when the number in front of that squared term is not 1. Okay, now again, keep in mind our overall goal. Our goal is to rewrite this as a product of smaller polynomials. What does that mean? Well, we're talking about a degree 2 polynomial, and remember, the degree of a polynomial is the highest power of x we have in the polynomial. So for this one, the degree is 2 because, again, we're dealing with x squared. All right. Now, what is it going to mean to factor that as a product of smaller polynomials? Well, if the degree is 2, the only way we're going to be able to express it as a product of smaller polynomials is if our degree is 1. All right. What is the degree 1 polynomial? X plus a number. All right. So the only way this is going to work in this situation is as we have it written down here, where we can factor this as x plus a number times x plus or possibly minus another number. Just a quick note also, when we write, you're going to see this done in math books all the times and in videos all the time. When we look at an expression written in this way, ax squared plus bx plus c, all these numbers, these coefficients, a, b, and this number c, they could also be negative. Alright, so don't just assume that those are always going to be positive values. We always write them with pluses just because it's simpler to do that, but those could represent negative numbers. We could be adding, say, negative 5x, and then adding negative 7 at the end. Alright, but for this, we're going to just write it as pluses as we explore this. Alright, now again, what we want to see is we can write this as a product of two smaller polynomials. And again, in between these parentheses here, I'm just going to put a little dot, is a multiplication. Now, what we're going to do is actually multiply this out. So what I want to do is multiply the right-hand side out. If it's going to be possible to factor it, we've got to have a linear polynomial times a linear polynomial. So when we distribute this out, we're going to multiply each term in the first polynomial by each term in the second polynomial. Alright, so that means we're multiplying the x by p and the x by x and x by q, then p times x and p times q. And let's just write out those terms. So we're going to get x squared plus px plus q times x plus p times q. Okay, and I've done this in the next step here. I've got it typed, but these are like terms right here. We can add those together by just adding the coefficients. Okay, so when we did the multiplication, we've got that down below here. What we're left with is x squared plus the coefficient of x is p plus q, and then the constant term is p times q. Now, how is that going to equal what we started with originally? Well, we want this to equal what we started with, which was x squared plus bx plus c. We're going to draw a conclusion from this that the only way it's possible if these things are going to be equal is if the coefficients are equal. Because we're seeing we can match up x squared with x squared. We're going to match the coefficient of x with the coefficient of x here, and then we're going to have to match the constant term with the constant term we're given in the polynomial. So our goal is to find these numbers p and q to make this factorization correct. Now, what's the conclusion we're coming up with? The only way this is possible is if the constant term c is equal to p times q, and the coefficient of x term, which we're given in the problem as b, is equal to p plus q. Okay, And that is what we're going to be using to factor polynomials where the coefficient of the squared term is 1. We're going to be looking for numbers, as we have it typed here. We're going to be looking for factors of the constant of the number c, which is the constant term in our polynomial, that add up to the number b, which is the coefficient of x. And this is the key right here in words. What are we looking for? Factors of the number c, the constant term of our polynomial, that add up to the number b, which is the coefficient of x. Alright, so let's get some practice working with factoring trinomials. This is a very important skill, so we have to be good at this and efficient at it. Alright, so I've got 4 examples I want to run through, and then we'll get some more practice in our homework. Alright, so let's look at this first one here. We got x squared plus 5x plus 6. So again, what we're referring to as c is the constant term, so c is 6. The coefficient of x is 5. Now, when we look at c equals 6, we want to think about all possible factors of that. We can write 6 as 1 times 6, 2 times 3, and that's the only 2 positive factors of that. Now, when we look at the factors 1 and 6, we want to think about adding them together. And the factors 2 and 3 and adding them together, which ones work here? Well, this adds up to 7, this adds up to 5. Okay, so what we're looking for is to find factors of 6 that add up to 5, and that's showing us that the winning pair in this example is 2 and 3. Okay, so this polynomial, by our analysis up above, factors as the product of 2 smaller polynomials, x plus 2 times x plus 3. Excuse me. Alright, we could also write this as x plus 3 times x plus 2. It doesn't matter the order you write your factors. Multiplication is commutative. Alright, so it does not matter in which order we write these down. Alright, I'm going to just move this down a little bit. I want to do a quick check here for this example. Alright, I'm not going to do it for the ones that come after this, but let's do it for this example. Now, if we were going to check our work, we would have to multiply these polynomials out, which means multiply each term in the first polynomial by each term in the second. And that would give us x squared plus 3x plus 2x plus 6. And then if we combine the like terms, the 3x and the 2x add up to 5x. So we get x squared plus 5x plus 6, which is what we started with, so that checks out. Alright, let's do another example now. Alright, so let's look at this next example. Alright, so now again, here we have to include the minus signs. Alright, so we got to be careful in considering the sign. Alright, so when we look at this problem, the number c we're talking about is not just 8, it's negative 8. The number b is negative 2. Alright, so for this example, we have c is negative 8. Now, what are the factors of negative 8? There are multiple ones. Alright, so we can use 1 and negative 8. We can use negative 1 and positive 8. We could use positive 2 and negative 4. Or we could use negative 2 and positive 4. Now, taking these separately and adding them together, 1 plus negative 8 is going to give us negative 7. Negative 1 plus 8 is going to give us positive 7. 2 plus negative 4 is going to give us negative 2. And then negative 2 plus 4 is going to give us 2. Okay, now what are we looking for? We want to know the factors of negative 8. We've listed the only 4 possibilities that add up to negative 2, and therefore the third one has got to be our winning pair. Alright, so for this example, we have the factorization that our given polynomial, the given trinomial, it's a 3-term polynomial, x squared minus 2x minus 8, sorry, my finger got me there, can be factored as x plus 2 times x minus 4. Or you could write that as x plus negative 4, but it's more convenient to just put x minus 4. I'm not going to check that, but I would encourage you to pause the video and check that by multiplying out those 2 binomials. Again, binomial means 2-term polynomial. We have accomplished our goal of factoring that trinomial as a product of 2 smaller binomials. Alright, let's look at the next example. We'll do 2 more in this video. Alright, so for this one, our factors of C in this case are negative 60. Now there's a lot of them in this case, factors of negative 60, but we want them to add up to positive 7. Alright, so let's think about going through and what our options are going to have to be. I didn't say this for the last example, but it was kind of seen as we worked it out. If we're going to multiply together to be a negative number, one of the numbers has to be positive and one of the numbers has to be negative. Now I'm going to write the list off kind of over to the right here, and then we'll think about what the winning pair's got to be. So when we think about 60, we could go 1 and 60. 60 is an even number, so it's divisible by 2, so we get 2 and 30. Divisible by 3 also, 3 and 20. It's also divisible by 4, that's 4 times 15. And it's divisible by 5 also, it's 12 times 5. You can use a calculator, start taking a calculator and do 60 divided by 1, 2, 3, 4, 5. And then the last one's going to be 6. 60 is divisible by 6. Now notice, I did not put on here any minus signs. Alright, I did not put any minus signs on here because what we want to think about doing is if we added a minus sign here, we would be adding or subtracting these numbers together. Alright, so we really would be adding a negative, which is subtracting. So thinking about doing subtraction with 1 and 60, the only way you could accomplish that if you put a negative on one of those and add them together is you're going to get either 59 or negative 59. Alright, with 2 and 30, if you add negative 2 plus 30, it would be 28. If you had 2 plus negative 30, it would be negative 28. Alright, and so on and so forth. Hopefully you can see by this inspection that the winning pair here has to be 5 and 12. We can get to 7 with 5 and 12, and we're going to have to keep more positive weight with the 12 and with a minus sign with the 5, because negative 5 plus 12 is going to give us 7. So that's the winning pair of factors. So my recommendation would be, if you have a negative constant term, think about adding and subtracting the positive factors to help you determine what the appropriate factorization should be. Alright, so we're going to get x and x. Alright, and we're going to have plus 12 minus 5 for this example. Alright, again, you can check it by multiplying it out. Alright, let's look at one more example, and that's this here. Alright, so for this one, our constant term C is 20. Our constant term B is negative 9 for this problem. Alright, again, we got to include the sign. So we're looking for factors of C, which is 20, that add up to negative 9. Now, what are the only possibilities for this? If you're having a positive coefficient, or positive constant term, but you have a negative coefficient of x, that determines to us that the numbers we're looking for both have to be negative, because we're looking for factors of 20. Two numbers that multiply to 20 then add to negative 9. Well, the only way you can multiply to a positive number is to either have both numbers be positive or both numbers be negative. Alright, but if both numbers are positive, they would add to a positive result. Alright, after you add them, if both numbers are negative, they're going to add to a negative result. So both of our numbers have to be negative. And just for time's sake, I'm just going to write the result down. We're going to use negative 4 and negative 5. All right, those are the winning pair for this problem. So we're going to get, in this case, x plus negative 4, which we can write as x minus 4, x plus negative 5, which we can simply write as x minus 5. And that is the appropriate factorization. All right, as you can check. These 4 examples do showcase all of the possible sign patterns. In this last one, the constant term was positive, the coefficient of x was negative, and therefore both of our factors had to be negative. The previous 2, the constant term was negative, and therefore one of them had to be positive, one of them had to be negative, as we saw in our results. In the first example, we had all pluses. The constant term and the coefficient of x were both positive, and therefore both of our factors had to be positive. Okay, hope you found this video helpful.